Hi, welcome to the section of Hadoop MapReduce. In this section, we'll be looking at how an Hadoop MapReduce architecture look like and what are the main phases of MapReduce. Followed by, we'll be looking at how to write an application of MapReduce for word count, and then we will see how to write an application for custom sentiment analysis. Followed by, we'll see how to do image analysis using MapReduce. Let's quickly discuss how a MapReduce architecture look like and what are the important parts of Hadoop MapReduce. In Hadoop MapReduce architecture, as the name signifies, there are two main phases. One is mapper and the next part is reducer. Please remember, these are the two main phases for which we write logic in let it be in Java or Python or whatever high level programming language it might be. But these are the two phases for which we write our logic. Let's look at how does we arrive at the output of a reducer starting from the input of the mapper. Okay, let's consider we have an input with group of records. First thing we got to do is we'll have to split the records, right? So we'll have to split the records and give as an input to the mapper. So how do we split the records and pass it as an input to the mapper? So if you could remember, there is a concept called block report or a block concept in Hadoop. The default block size in Hadoop is 64 MB, right? So when you have configured 64 MB as your block size, right, and we split the input file based on the block size. If this input is 3 multiples of 64 MB, then the input will be split into 3 parts so that each part will be going as an input to one particular mapper. Let's assume a situation where this input file is 3 parts of 64 MB. So the first part, second part and third part will be going to the mapper 1, mapper 2 and mapper 3 respectively, which is of 64 MB, 64 MB, and the last split will be either greater than 64 MB or lesser than the 64 MB. Okay. Now we have split the file. Our first job is done. Now that will go as an input to your mapper. Okay, so what would be the specific input parameter to your mapper? One would be your offset address, and second thing would be your block which we have split basically. So the first thing is offset address. So what is this offset address? Right. So offset address is nothing but the starting and ending address of your particular block which you are passing as an input to the mapper. Because your mapper does not know from which part to which part it should take as an input, right? Because from the picture we know that we can segregate that this can be one block and this can be one block and the last can be one block. But how would mapper know that this is one block which it has to take as an input, and how would mapper 2 know this is another block which it should take as an input? And similarly, how would mapper 3 know that this is the block that it has to take as an input, right? So in order to make your mapper understand that this is the block that it has to take the input, we will pass the offset address. Offset address is nothing but the starting address of your record as well as the ending address of your record, so that it will take that particular block as an input. So kindly remember, we will pass offset address and your actual content as an input to your mapper, because this is pretty important while we are writing the mapper logic. Okay, and similarly the second mapper will contain the offset address comma block of the records as an input to it. Similarly, mapper 3 will have offset address comma the content as an input to it. Okay, Now each mapper has got its respective offset address and the block. Once the mapper picks this particular block, it converts that into string and tokenize them into words. Tokenizing is nothing but it is breaking them into words. First of all, it will convert this into string and then tokenize or break them into words. Right? So once it has broken them into words, the mapper output would be key comma value, which is nothing but a word comma 1. I'm just trying to explain, or I'm just trying to explain how a mapper output can be. Okay, once we pass offset address and block as an input, right, your mapper will convert that into string and then it will tokenize them into words and then it will generate a key value pair. Okay, so the output of the mapper would be key value pair, and similarly your output of the mapper 2 also would be key value pair, and output of the mapper 3 also would be key value pair. Once we get key value pairs, there would be shuffling and sorting happening on key of the mapper output. I'm repeating, once we get key value pairs as our mapper output, there will be shuffling and sorting happened on the key of each of the mapper's output. Once sorting and shuffling is happening, that will be the output of the sorted phase will be the input to the reducer. Reducer will combine the result and give it as a consolidated output to the client. So once we get the output of the mapper, as discussed, we will be having shuffle and sort phase on key of the mapper output, right? So the input to the reducer would be key comma value pairs. Okay, key comma values pairs. So it can contain one key and multiple values as an input. Like that, it can contain any number of pairs. So the output of the mapper would be key value pair and input of the reducer would be key and values. Okay, so now what happens is reducer will combine your final result and give the consolidated result to the client. So let me repeat the architecture once again. Once we have an input, which is a group of records, we pass the block of this particular input as an input to the mapper, and in order to make mapper understand that this is the particular block it has to pick as an input, we pass offset address to the mapper. Offset address is nothing but the starting address and the ending address, right? So when each mapper gets this as an input, they convert that input into string and tokenize them into words and generates key value pairs. Once mapper output arrives as key value pairs, we do shuffle phase and sort phase, after which we get key and value pairs. Okay, this sort and shuffle phase is mainly due to the similar keys will go to the single reducer. This avoids this reduces the burden of reducer. We'll discuss about all these things what we are discussing in the architecture with an example of word count, which would give you a good picture of how MapReduce application will work like. But just to remember, there is something called mapper which would generate key value pair, and again the input would be input of the reducer would be after the sort and shuffle phase, and output of the reducer would be a consolidated result which we would be giving it to the client. So one important thing we got to consider over here is we will be writing logic for your mapper code as well as a reducer code, but not shuffle and sort, because shuffle and sort are something which are internal to the Hadoop architecture. So you don't need to explicitly code for your shuffle phase and sort phase. And another important thing to remember in this architecture is the output of the mapper would be stored in the temp of your temp directory, but not in HDFS. Whereas the output of your reducer will be stored in HDFS. The reason for not storing mapper's output in HDFS is mapper's output is an intermediary result which we don't require after a reducer's output is generated. As it's an intermediary result which we don't require in the future, we don't need to store it in HDFS and replicate it by 3-factor, which is the default replication factor. So in order to avoid that, we are not storing mapper's output in HDFS, rather we are storing it in temp path, so that once your reducer is done, you don't need this mapper's output, because once the temp path is full, your file system will automatically flush off your temporary results, right? So mapper's output would be stored in temporary path, whereas reducer's output would be stored in HDFS. And another important thing which I had told is mapper and reducer is a two logic which we would be writing in our coding, but not for the shuffle and sort phase, because shuffle and sort phase are something which are internal to the Hadoop architecture. That's it for this Hadoop architecture. Hope you had enjoyed watching this video. Thank you so much. Bye bye.